Alright, what I'm going to demonstrate here is how to solve for two unknowns, two unknown variables. Let's say that you're working through a problem, a physics problem, for example, and in trying to work out your puzzle, you find that you have two things that you don't know. And it's kind of hard to solve your puzzle with two pieces missing. Fear not, though. As long as we can relate our two unknowns together with two equations that use both of them, for example, we should be able to solve our puzzle. So the first method I'm going to demonstrate is called substitution, and you will see why momentarily. So what I'm going to do to start out with is I'm going to take one of my equations, and I'm going to take my bottom one and rewrite it to solve for x. I don't know why my blue is different. Alright, so I'm going to get x all by itself. All by its lonesome. So divide both sides by 5, which is going to give me 3/5 y plus 4/5. And I'm just going to write it out in decimal form just to make it easier. So that's going to be 0.6y plus 0.8. Alright, so I have one equation solved for x. And now what I'm going to do with this equation is I'm going to take it and I'm going to plug it into the x of my other equation, which does a nifty thing. So let's plug it in and see what happens. Plus 0.8 plus 2y equals 8. Alright, and we have to multiply this out to simplify it. It'll be 1.8y plus 2.4 plus 2y equals 8. Alright, so let's have a look at this. So I only have one unknown now. Yay, substitution. So now what I can do is I can combine my like terms. So I'll subtract 2.4 from both sides and then add my 1.8 and my 2y together. So that'll give me 8 minus 2.4 is 5.6, and 1.8 plus 2 is 3.8y. Now I can solve for y. 5.6 divided by 3.8 to get y is equal to 1.47. Alright, so now I have one piece of my puzzle. And now what I can do with that one piece is plug it into one of my two equations to solve for x now. And I think I'm going to plug it into my top equation. So, right there. So, 3x plus 2 times 1.47, which is equal to 2.95. Alright, 8 minus 2.95 is 5.05. That's equal to 3x. Divide both sides by 3 to solve for x, which gives us 1.68. Now I have my two unknowns. Alright, so this is my preferred method. The next method, which I will show, is just as effective. I guess I'm just too impatient for it. And I don't like multiplying equations out if I can avoid it, so. Alright, so the idea behind equation addition or subtraction is I need to get rid of one of my unknowns again. In substitution, we did that by writing x in terms of y. But there's another way we can do it. And today I think I'm going to pick on y. Excuse me. Because I have a positive number up here and a negative down here. So imagine if both of these numbers were actually the same number, then when I add them together, they'll cancel out. So what I'll have to do is I'll have to multiply both of, yes, black, both of my equations by a number to make my y coefficient the same number, but opposite sides. So I think the easiest way to do that will be to multiply this top equation by 3. That will give me positive 6y, and multiply this bottom equation by 2 so that I'll have negative 6y on the bottom. So let's rewrite these equations. That's an arrow. Alright, 9x plus 6y equals 24. 10x minus 6y equals 8. Alright, so yeah, this is set up very nicely. So when I add these two equations together, this is going to be 32. Positive 6 minus 6 is 0, so no 6's carry down, no 6y's. And here I'll get 19x. Now if I solve for x, I should get a familiar number, 1.68. Yep, same number I got when I used substitution. So now I can pretty much do the same second step as last time. I can take my x, plug it into one of my equations here to solve for y. And I think I'm going to use my top equation again. 5 plus 2y equals 8. This is starting to look very familiar, isn't it? Yep. See that 5.05 there? .95 divided by 2 is 1.475, 1.48. Close enough. Alright, so as you can see, both of these methods work for finding your two unknowns. Alright, and lastly, I'm going to do an example with a vector problem. So let's say I have a vector of magnitude 9.49. And let's say the angle of this vector is unknown. However, it is a vector and it's two-dimensional, so we know that it must have, get on the right layer, alright, it must have an x component and a y component. So I always like doing this with vectors. They turn into right triangles very nicely. X component, y component. Alright. And let's say that the other bit of information I'm given is that my y component is 3 times the length of my x component. Okay. So, and we want to know what x and y are. Okay, there's one other equation I can use. It's a triangle, so I can use Pythagorean theorem, which is a squared plus b squared equals c squared. Happily. Alright. And our hypotenuse is 9.49, which squared is approximately 90. Alright, so I've got two equations. So via substitution, this is already nicely written, so I can just plug it in. 3x squared. Don't forget to, do not write it as 3x squared. Don't forget to square your 3. Otherwise your numbers will not be happy. Not happy numbers at all. Should come out to 9x squared. And add our like terms together, we'll get 10x squared. And if we solve for x, 90 divided by 10 is 9. And 9 squared is 3. So x must be equal to 3. And if I take this and plug it back in here, 3 times 3 is 9. So via substitution, that's how it works. And let's use our equation addition method as well, just practice. Okay, so I'm going to have to do something before I can add these two equations together, because these x's and y's are in terms of x squares and y squares, and this is just plain x and y. So let's get this in terms of x squares and y squares by squaring both sides of the equation. So again, don't forget that your 3 is inside the parentheses. And let's get everything on the same side of the equation. Alright, so x squared plus y squared is equal to 90, and 9x squared minus y squared is equal to 0. Alright, so my y's are already ready to be canceled out pretty much. Y squared minus y squared is 0, so I can just add these two equations together as is. 90, cancel, and then 10x squared. And you notice I have the same exact equation which I had up here. So I would solve for x the same way as before, plug x into one of the equations to find y. So, alright, that's my video on solving for two unknowns. Thank you very much for watching, and if you have any questions or comments, please leave a comment or message me. Thank you very much.